I will kind of buzz through the beginning. So today we'll talk about OLTP versus OLAP and ETL. OLTP stands for Online Transactional Process. This is in contrast to OLAP, or Online Analytical Processing. So far, we've worked with OLAP or OLAP to finding better ways of organizing our data for querying, mainly by reporting tools such as Power BI or Tableau. Today, we'll talk about OLTP and how to go from OLTP to OLAP using ETL. OLTP is for maintaining transactional data in a database. The emphasis is on fast processing, as data is updated frequently, most often daily or near real time. Data integrity is usually maintained in that we want to ensure we get all the data and isolate any discrepancies in how we ingested the data. OLTP is usually high frequency and only stores a certain amount of data, usually a day's worth, before it gets overwritten by the next day's data. We perform ETL and move the data to historical storage where we have storage and compute considerations. By limiting the amount of data and simply adding or removing rows, we are adhering to storage and compute considerations for OLTP. The use case is different, and thus the compute considerations are different. OLTP prioritizes updating the data, whereas OLAP prioritizes querying and searching through the data. Let's go over two common scenarios: social media and customer sales transactions. If we were grabbing data from Twitter, we might collect various tweets, their impressions, likes, and comments. We would write a script that collects the tweets from today or maybe the last couple of days. We could also do this for sales and transactions, grabbing all the transactions for the day. We could either store this in a raw format where perhaps there are multiple items in a row, or we can do a little lift here and create a new row per customer item transaction, right? So we have a customer, we have the item that they bought, we have a transaction. This data is then staged in our staging layer. Do I have a good picture of this? This would probably be, so here, this kind of staging branch level. Many times you will see a separate schema or a database dedicated to this process, usually DBO or ST prefixes. You may be wondering, if we grab more than one day of data, won't we have duplicate rows in our historical data? Most data has a unique identifier for the smallest granularity. If it doesn't, we can generate an index and implement a system for maintaining the index. During our ETL, we can implement a system to filter out rows that have already been added. So here we have the details for this transaction, 483, whatever, and here's the transaction ID within the data. And you can see this is, in this case, like a Bitcoin in the Bitcoin ledger. So each transaction has a specific ID or hash ID that allows us to identify it. If it's already in our database, then we don't have to add it in. If it isn't, then we do add it in. So it doesn't really matter how much data we collect in our staging database, as long as we have at least every row one time. So again, during our ETL, we can implement a system to filter out rows that have already been added, as I just said. ETL stands for extract, or export, transform, and load. Our OLTP is our extracting. For example, we've now localized the Twitter sales data in our staging database. It's now within our database, and so we've extracted it. From here, we'll need to transform our data into the right format, into our normalized format that we talked about before, and then we need to load it into our OLAP layer. And so this is kind of an insert kind of operation. This is probably the most complicated part of the ETL, that is the most complicated part of data engineering, if we're not considering like sourcing the data. Maybe someone wrote us a script to ingest the data, or it's already part of a built-in feature of the system. The most coding you're going to do as a data engineer is either querying data to get something special, or really this kind of ETL process. This is the heavy lifting of all data engineering jobs. This is our data will come in a denormalized format, as we've talked about before. Dimensions and facts will be contained in one table, and a lot of information will be repeated. So generally in OLAP, we want to avoid denormalization, but in OLTP, this is fairly normal. And the question is, how do we normalize our data and update our dimensions in our fact tables? In a normalized star schema, we connect our dimensions in our fact tables with primary and foreign keys. We'll need to generate our primary keys in our dimension table before we reference them as keys in our fact table. So you can see here, we have our, our dimension queries and our fact queries, and they both go to our staging. But within the staging step, this staging has to go to the data mart first, and then this data mart will inform how the fact staging goes into the fact storage or data mart. So generally, when we build our ETL scripts, we're going to launch our dimension scripts before our fact scripts is basically what I'm getting at. Thus, our first step in our ETL is to search the data for new dimensional values. Uh, we need to separate the dimension or categorical information into groups. For example, let's say our sales data pertains to multiple stores and each store has a location. Locations are comprised of region, country, state, and city. Given that there are cities with the same name, we could look for unique combinations of region, country, state, and city that are not already in our location dimension and add a new row. We would then assign a new location ID for this new row, oftentimes one greater than the last one in the system. We could also index with a certain pattern if we had to organize this beforehand. Before the country change the first digit, or sorry, for a new country, we might change the first digit. For a new state, we might change the second and third digit. For a new city, we might change the fourth, fifth, and sixth digit. And that way our index will always maintain a certain order to it based on uh, where we're talking about in terms of location. We would do all of this kind of pattern of looking up dimensions if they already exist, and if they don't, create a new one. We would do this for everything except for date and time. For our date and time dimension, our granularity is fairly consistent, right? It's always going to be number of days and amount of time. Or maybe we have a fiscal calendar, but we can assign that, 10 years in advance. For this, we're really just going to query the max or min of the date type of data and manually add or we could manually add these parameters into our date and our time queries. So that's here, dates are fairly standard. There's no need to do an ETL around date and time. We can just write a table or a SQL script that generates a table for us. But we don't need to update this every day, right? From here, we would generally load in the staging data row for row. However, we would switch out the lowest granularity of each dimension with the respective, sorry. Next, we would basically do the same thing for our fact tables, where we're going to load it in row for row. One transaction in our fact table is going to be one row in our data mart. However, instead of location or instead of customers or sales representative or item, we would replace this with the ID that we created in our dimension data mart. And so that's why we have to do the dimension data mart first, is because then once we create it, we would look up, hey, what is things in our item dimension? What customer ID is Phyllis Johnston in our customer table? What region, or in this case, location, because it's a smaller granularity than region, what ID is New York in our region table? And then we would replace all of these with our IDs instead of the actual name as part of our normalization standards and keeping our data as concise as possible. This allows us to adhere to normalization principles as well as set up our model for referential success. As mentioned, ETL scripts can be divided into two categories, those pertaining to dimensions and those pertaining to facts. Dimensions need to check for unique combinations that have already been stored. Facts needs to reference these combinations. Some staging layers take care of this work for us, but not always. For all ETL scripts, we will have 4 sections: delete and clean step, add new data step, update old data step, and audit. In step 1, we are deleting rows that ought to be removed. For example, if we were doing a budget, we may only want the current budget, so we would remove any budgets that don't pertain to our collection. Any filter steps for our data mart occur in this step. In step 2, we add new data. Generally, we use our matching on either rows or indexes here. In our dimensions, we were adding new unique combinations of dimensional data. In our fact table, we are adding new rows of facts if we haven't already loaded them. Again, this is where the unique fact transaction ID comes in. In step 3, we're updating old data. Where we have duplicate transaction IDs in our fact table, we can update the data. For example, maybe we got the item wrong, and then our staging picked this up, and we can, update our old rows. We can ascertain that something is qualified as different by checking a few columns, such as, say, the item column or the customer column, or we can just completely replace the rows regardless. If we choose the latter, we may consider removing these duplicate rows from our staging or our fact in step 1. However, this may disrupt an outside indexing if we had on our fact table. For example, the checks, like if we assigned an index after the fact because we just wanted a new index. However, something like transaction ID would be maintained by definition, right? We only were able to replace it because we knew it was a duplicate transaction ID. So if we deleted the original row and added the new one in, that transaction ID would still be there. It's just our own outside indexing that might be affected. So just a consideration for step 3. In step 4, we might add an audit step. This is optional but highly advised. During our ETL, we can capture information about our staging, fact, and how many rows were changed in each step of our ETL. We can then push this information along with an ETL ID into an audit table. This is great for monitoring the historical progress of our ETL and allows us to find when an error may have occurred. We can similarly do this with our staging table using triggers. Keep in mind that when the data is loaded in staging tables, this is an outside process, and thus there is no ETL script to add the audit step in. We use triggers to monitor changes in the table and can link these back to the audit table. So here's kind of an example of the adding step or step 2 of a stored procedure. Generally, we handle OLTP and OLAP in a SQL database. All databases have schema that allow us to separate our tables. But even without schema, we could label our tables starting with an ST prefix for staging or a MART prefix for our data mart. ETL is usually launched using stored procedures. These are written and maintained in the database as well. We can also manually launch stored procedures from the database UI, such as in SQL Server Management Studio. Given the Studio is launching via the CPU of our computer, this makes sense. We could also write a cron or schedule script to launch these stored procedures via our CPU as well. However, this won't work if our computer is turned off. Because of this factor, and because we tend to prefer to automate everything fully, in order to launch stored procedures, we'll need to launch them via a scheduler cloud app, such as Azure Data Factory, Oracle Informatica Online, or AWS Glue. All of these are serverless services that allow the launching of stored procedures using CPU, or rather DPU, or database processing units. As noted, these used to be handled on premises with services such as SSIS, or SQL Server Integration Services. So when we do our actual project, we will build our tables in SQL Server Management Studio. We'll also build our stored procedures in SQL Server Management Studio. And then we will use Azure Data Factory to launch our stored procedures and move data from our staging databases, which we'll label with DBO, to our data mart, which we'll label with mart prefix. So yeah, that's it for the lecture. I hope it was helpful, and we'll really get into a lot of these in practice with our project. Are there, oops, I'll share right here. And then we can stop recording.